talk about some triangle congruence postulates. And a postulate is something that has been proven that we can follow along with. So if you look at these two triangles, you see that they already have three congruent corresponding angles as well as three congruent corresponding sides. So we know that these are congruent triangles, and we can write a congruency statement, such as triangle ABC is congruent to triangle JKL. Now, what we also have learned from these postulates that we're about to see is that even if you don't have every bit of information, you can still prove two triangles to be congruent. So there are four postulates we're going to talk about. The first one is the side-side-side, or SSS postulate. Before we learned about some similarity theorems that were just like this, but this is a new one. Alright, so the side-side-side postulate says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So if you look at example 1, we have three sides on this one and three sides on this one, so we know that they are congruent. Another congruence postulate is side-angle side, or SAS postulate, and it says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So if you look at example 2, we see our two sides. Remember, we know that this angle is congruent to this one due to the vertical angles postulate. So we can say that this triangle is congruent to this one through SAS. Go back, we said this was side, side, side. Look at example 3 over here. I have this side congruent to this side congruent to this side, and then they share a side. So obviously, if they're going to share a side, they're going to be similar, or excuse me, congruent. So we can also say that this triangle is congruent to this triangle by side, side, side. So those are your first two triangle congruence postulates. Let's look at the next two. The angle side angle, or ASA postulate, says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So look here at example 10. It's also 10 in your notes. We have these two sides. These two sides and this angle, and these two sides and this angle, but that doesn't prove angle, side, angle. That proved side, angle, side. So let's look over at this one. Let's say that this angle and this angle are congruent. Now, still dealing with angle, side, angle, if we have this angle and this angle congruent, and again, here's our vertical angles, so we know that they are congruent, we can prove example 11 congruent by angle, side, angle. Okay, another postulate, and the last one we're learning today, is angle, angle, side, or AAS. It says if two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the two triangles are congruent. Well, you know that the included side means like right here between your two sides, or in this case, angle and angle with the side in the middle. Look at example 2 over here. We have this angle, we have one side. Same down here, one side, one angle. But again, the vertical angles postulate tells us that these are congruent. So now we have angle, angle, side. Angle, angle, side. So we can say this one is congruent by angle, angle, side postulate. There is no angle, side, side postulate because there's no donkeys in math class. If you look on your notes, you have quite a few examples of all four postulates. I'd like you to do all of those at home, and we'll go over them in class tomorrow.